Alright, today I'm going to be going over the study guide for the test that you have coming up on Tuesday / possibly Wednesday if school gets canceled. So the first thing I'm going to do is go over the table of terms. And so let me just slide this over here. Okay, perfect. Now, the table of terms, I will post an image of this completed table in attached to the video, but what I'm going to do right now is just go through it step by step. Alright, so the term is velocity. The variable for velocity is v with an arrow above it. The standard units are meters per second. The variable for m is mass. The standard unit for that is kilograms. Newtons, that is a force. Variable is F. Height, the variable is h. Standard units are meters. Work, the variable is AW, and the standard units are joules. Kinetic energy is KE. Standard units are the same as work. Joules are J. And PE must be potential energy. Units are also joules. J once again. Total energy is TE. Units are joules. Would you look at that? There's a lot of joules. Change in energy. This one was giving some people some issues. Delta E. Also joules. Now the nice thing is that delta E over here is the same thing as work. So work causes a change in energy. This is an important thing to keep in mind. Work is, yes, force times displacement, but the force times displacement causes a change in energy. So when you do work on an object, you increase that object's energy. So for example, if we think of the conveyor belt on the roller coaster, you say you have a little bit, say you have a roller coaster, right? You got a roller coaster like this, chugging along. Now the roller coaster has no potential energy at the bottom, but at the top it has a ton of potential energy. The only way it can get all of that potential energy is if the conveyor belt does work on the coaster. The conveyor belt has to apply a force and cause a displacement in order to add energy. So work is a change in energy, same thing. Finally, watts. The variable for that is a P. That is because the term is power. So things to keep in mind: work has a variable W and is represented by joules. Or work has the units joules and is represented by a W. Power has the unit watts and is represented by P. This can be confusing sometimes. Just remember joules for work, watts for power. Joules for work, watts for power. Alright, moving on. Cool, we're at 3 minutes. Equation sheet. The only big equations that you need to know for this test, or the big equations that you need to know for this test, include F sub G is equal to mass times gravity. That is the formula for weight. In addition, you should know that work is equal to force times displacement. You will also be given these equations. You should know that KE is equal to 1/2 mv squared, and you should know PE is equal to mgh. You should also know that E total is equal to kinetic energy plus potential energy. And you should know that power finally is equal to work over time. I believe that's every big formula that you need to know for this test. If there are others, please let me know in the comment section below or send me a message on the Remind. Alright, so now what I'm going to do is go over the multiple choice questions. I'm going to go over these multiple choice questions, and then I'm going to post the solutions also in the Remind. Okay, let's start with kinetic energy. Rock is dropped from the top of a building. As it falls, it is getting faster and faster. Which of the following is true about the rock's kinetic energy? If it's falling and it's getting faster and faster, obviously its velocity is increasing. And if its velocity is increasing, then its kinetic energy, if kinetic energy is equal to 1/2 mv squared, if velocity is going up, then kinetic energy also has to go up, so its kinetic energy must be increasing. That is C. Alright, calculations. Box with mass 20 kilograms is sliding along the ground with a velocity of 8 meters per second. What is the object's kinetic energy? K is equal to 1/2 mv squared. 1/2 times 20 kilograms times 8 squared. That's 10 times 8 squared is 64. It should be around 640 joules. So that answer is A. Potential energy. Moving on. Mountain climber is hiking down a mountain, getting closer and closer to the bottom. Which of the following is true about her potential energy? If she's going down the hill, then her height is going down, right? She's going down the hill. That means MGH is going down. Because the height is going down, the whole potential energy is going down. Her potential energy is decreasing. It's going down, down, baby. Just like, I think that was Nelly, right? Nah, I don't know. Okay. Calculation. Teddy bear, 4 kilograms, is sitting on the top of a shelf and his potential energy of 98 joules. What is the height of the shelf? Ooh, easy. Potential energy is equal to MGH. What is the height? You don't know what H is. So H is equal to potential energy divided by M times G. In this case, we know the potential energy is 98 joules. I'm sorry about that. The lights in my room just turned on. Oh, turned off, actually, but it looks a lot better on the under the document camera. Okay. Potential energy is 98 joules. Mass is 4 kilograms. Times 10 meters per second squared. That's around 98 divided by 40. That should be around 2 something. Let's call it 2.5. Cool. So that puts us at A for this one. Total energy calculation. Okay, so we know that the toy airplane has a mass of 10 kilograms, velocity of 9 meters per second. Toy airplane is flying exactly at 25 meters above the ground. That's a height. Calculate the total energy of the toy airplane. All right, total energy. We saw from the first table that we wrote that total energy is equal to kinetic energy plus potential energy. First we need to find that, and then we need to find that. We have enough information to do both of these things. 1/2 mv squared plus mgh. So 1/2 10 kilograms times the velocity squared. That's 9 meters per second squared plus m 10 kilograms, g 10 meters per second squared, h, which is 25 meters. Gives us a pretty big number. This is not going to be a small number. So that's 5 times 81. So that's around, whatever. I'm just going to put it in my calculator. Ain't nobody got time for that. So 0.5 times 10 times 9 squared plus 10 times 10 times 25. Let's see what we get. 2,905. All right, that is kind of different from a couple of these answers. I guess the closest one is D, and I think that is the correct answer. Yeah. So we're at D. This one. You know what the difference was? I know why. Obviously 10 meters per second squared, 9 meters per second squared, or 10 meters per second squared instead of 9.8 will give you that difference in rounding error. All right. So the answers for the first page are C, A, B, A, D. All right, moving on to the back page. We are at 7 minutes. I have to move faster. Okay, this is going to be a long video though. All right, conservation of energy. Okay, figure represents a pendulum's motion with the lowest point of its swing labeled P. Okay, that's the lowest point of its motion. So it starts up here. What happens to most of the pendulum's potential energy as it reaches the lowest point P? All right, so if it goes down to point P, that means that it has to decrease in height. That means that it has to decrease in height, decrease in potential energy, increases in kinetic energy, right? Because if the potential energy goes down, kinetic energy goes up, and the speed goes up, because the total energy stays the same. E total stays the same. Does not change. So potential energy goes down, height goes down, kinetic energy goes up, velocity goes up. So it must be transformed into kinetic energy. Inertia, no. Thermal, what? There's no friction. Chemical energy, we never even talked about that. Alright, so the answer has to be B for this one. Calculation. Student drops his alarm clock out of a window. The alarm clock starts from rest and has a potential energy of 39 joules. What is kinetic energy of the clock the moment before it hits the ground? Most people are going to see this and be like, oh, yikes, I have to do some calculations. But wait, there's more. There isn't. That wasn't even relevant. Okay, alarm clock over here has 39 joules at this height. Potential energy. That is also energy total because it's not moving. So the potential energy starts from rest that it only has potential energy, right? Now, all of that potential energy is going to go into kinetic energy. So as it falls, before it hits the ground, it's going to have whatever potential energy it had at the top. So 39 joules of kinetic energy. Whatever potential energy it had at the top is going to turn into kinetic energy before it hits the ground. So E total must stay the same. So because the height is pretty much zero the moment it hits the ground, there's going to be no potential energy and there's going to be a lot of kinetic energy. So kinetic energy of the clock the moment before it hits the ground must be 39 joules. some people might say, wait, but isn't it hitting the ground, so the height has to be 0 and then it stops? The height is in fact 0, but because it is asking before it hits the ground, the question is really asking you not what's the speed after it hits the ground. It's asking you what it is before it hits the ground. Obviously, if it hits the ground, it's going to be 0, the speed. But before it, you have to use the conservation energy to figure that one out. Okay. 3 kilogram block is rolling with kinetic energy 1800 joules. It reaches the ramp and rolls up the ramp until it comes to a stop momentarily. What is the maximum height of the ball on the ramp? Okay, so we have a mass here of the soccer ball. We have KE of 1800 joules. We know that it goes up a ramp and it rolls up. No, so over here it has some kinetic energy. At the top, at the very top, it'll have potential energy, right? All that kinetic energy is going to go into potential. Now, before it starts going down, you know that all of the kinetic energy it had is going to go into potential energy here. So potential energy at the top has to be 1800 joules. Now, if it's 1800 joules, we know mgh is equal to 1800 joules. We can solve for h. So 1800 joules divided by m times g. The mass is 3, g is 10. 1800 divided by 30. We get around 60 meters. So that should be 61.2 or 60. So the answer is C for that one. Alright, power. Alright, a brother and a sister decide to have a race up a hill. They have the same mass. Okay, they both start at the bottom of the hill. Brother gets to the top of the hill in 15 seconds. The sister gets to the top of the hill in 12 seconds. Once they are both at rest at the top of the hill, which of the following is true? Okay, so height is the same, mass is the same between these two characters. So if the height is the same and the mass is the same, the work done is going to be the exact same. Mass is the same, height is the same, g is going to be the same. Now, the work we know is going to be the same between the brother and the sister. However, there is going to be a difference in terms of power. Why do we know that? Because power is in fact equal to work divided by time. Right? If you look back at our formulas, you can see it's work divided by time. If the work is the same, but the brother gets to the top in 15 seconds, he must take more time because the sister gets to the top in 12. So brother takes 3 more seconds to get to the top. That means that this bottom number is going to be bigger. If the bottom number is bigger, that means that it's going to have less power overall because you're dividing by a bigger number. So like for example, if you have the same amount of work divided by 2, it's going to be less and less if you divide by 3, if you divide by 4, if you divide by 5, if you divide by 6. You're breaking that into smaller parts. So just by algebra, you know that the sister had a greater power output than the brother. Remember, same work. If that work is being done quicker, then then one of those objects is going to have a greater power output. So the answer is D in this case, because the sister had less time. Now we got a nice light work loss problem. 2,500 joules of work in 4 seconds. What is the power output? P is equal to W over T. In this case, we got 2,500 joules divided by 4 seconds. That gives us around 6.25 watts. So deep. Alright, bet. We are at 13 minutes. We are going to now move on to the free response questions. If this was helpful, please let me know. If it wasn't helpful and you needed extra help on a particular section, also let me know about that as well. You can do that in the comment section, send me an email, send me a remind message. Anything is fair game. Alright, so GP, we got to do a roller coaster, a pendulum, and a stair climber. So let's get started. Okay. And these are the only 3 problems that you're going to see on your test on Tuesday/Wednesday/whenever the devil we have school again. Okay, so for each type of problem, you should feel comfortable solving for anything that is possible to be solved for. Alright, let's do this. So we have some information here about a roller coaster. We know that it goes up to 35 meters, it goes back down to some height, and then it goes back up to a height of 28 meters, and then back down to a height of 15 meters. Okay, now the important thing to establish here is that this line is basically saying that it's 0. Height is equal to 0 here. Right, like here if it's 15 meters, and here if it's 28 meters, and here if it's 35 meters, it's all being measured relative to this line. This height can be 0. We don't have any other information that says otherwise. So we know that this height is 0. Okay, so the total energy at point 1, because we know its velocity at point 1 is 0 meters per second, we can say, we can fill this in right over here. We know that kinetic energy is going to be 0 joules. So PE is equal to, let me just write out the formulas real quick up here. Kinetic energy is going to be 0 joules. Potential energy is going to be the thing that determines the overall potential energy is going to be what determines the total energy at this point. That means that if we have a hold on one second.